Okay, so on question 9, it's going to be it's the end of the project. We're going to compare our height in meters to the fastest competitor in our event and see our proportional race length and how fast we'd have to run to beat them. So first you have to find your height in meters. If you know your height in inches, I'm 6 foot, which is 72 inches. So you can just come here and Google inches to meters, inch, meters. So 72 inches is 1.83 meters, just round to the nearest 100. So I'm 1.83 meters tall. And then, so I'm going to write that down, 1.83 meters. And then I'm going to go to my results. I'm going to find my fastest competitor. For me, it's Andre. They have the lowest time, who's 1.76 meters. And I'm going, my ratio will be their height, 1.76, to your vent distance. For me, that's 200. Okay. And then I'm going to, that's my ratio, 1.76 over 200. And it's going to equal my height. Well, your height. For me, it's my height over X, just like we've done. So now we can cross multiply and divide. So the first thing we're going to do is we're going to multiply your event distance, for me 200, by your height 1.83, and that is 366. So I get 366 right here, and then you're going to multiply 1.76 by x, and that's going to equal 1.76x. Well, you're going to be doing, obviously, your fastest competitor. For me, it was 1.76 x, and then you're going to divide 366 for me by 1.76. So we got my calculator, 366 by 1.76, 207.95 is what it equals. So my proportional race distance is 207.95. Okay. And I'm actually taller than my fastest competitor, so my race was longer than the original. Most of you are going to be shorter than your fastest competitor, so your race will be a little shorter. So it's going to be really hard for me to win. But some of you, it'll make more sense in terms of the speed will be more doable. So anyways, you get your proportional race distance. For me, it's 207.95. And now we're looking for, on question 9, we're looking for our speed. The speed it would take to get the gold medal at our proportional distance. So to find a speed, you take a distance and you divide by a time, and it equals a speed. Okay, and I already have a distance up here, 207.95. So I need to take a distance and divide it by a time to get a speed. Okay, so the time we're going to use is you're going to look at the time of your fastest competitor. For me, it's 19.62. And then you're going to take 1/100th of a second off. I want to see how many you got to beat them. So we're going to beat them by 1/100th of a second. So for me, that's 19.61. So you're going to take your proportional distance and divide it by 1/100th of a second faster than your competitor's time, your fastest competitor's time. So you're going to have 207.95 divided by, for me, 19.61. And that's going to give me the speed here. You're going to go to your calculator, 207.95, 207.95, and I'm going to divide that by 19.61. You're going to get 10.6. That's going to be a speed in meters per second. So the speed I would need to win my proportional race at the Olympics would be 10.6 meters a second. A lot of you are going to get a speed that's less than the speed of your competitors because your race is going to be shorter. For me, I ended up needing to win. I need a speed that's actually faster than any competitor. I'd have to run faster than anyone in the world to win my proportional race length. So if you go to question 9, it says You determine your height in meters. We did that. Calculate the proportional race length you would run if the fastest competitor ran the original distance and you ran a distance proportional to your height compared with theirs. So that's what we did here, where we figured out if their height was equal to 200 meters from my event distance, what would my height be equal to? And it was, what would my event distance be equal to? It'd be 207.95. And then we're asked to figure out the speed we would need to run to beat them. I did that, 10.6 meters a second. And then we're asked, is this realistic? So for me, it's not. I'd have to be the fastest human on Earth. So that's not realistic. You can give me a one-sentence explanation on this. You know, take the speed you would need and compare it to the speeds you figured out in question 1 and see if it's realistic that you could run that speed. And that's it. And then you finish the project.